Okay, so today we're going to talk about multiplying and dividing fractions, and that's going to include multiplying and dividing mixed numbers. We're going to start off with talking about multiplying. I know they kind of go together. You have to know how to multiply fractions in order to be able to divide fractions, but we're just going to focus on multiplying first, okay? So to multiply, do you need to have the same denominators in order to multiply? No. So do not need common denominators. Now, because we do not need common denominators, that's going to save us a lot of time when we are adding and subtracting those fractions and we are trying to find the common denominators. That often took the longest amount of time for us. All right, so there's 3 basic steps that you're going to follow. The first thing that we're going to do is we are going to multiply the numerators. Then we're going to multiply the denominators. And then always you should check to see, can you simplify? So you multiply straight across on top, multiply straight across on the bottom, and then see, can you simplify? So if you had a problem like 1/4 times 2 over 5. Again, it doesn't matter that they have different denominators. We're going to multiply straight across. 1 times 2 is what? 2. And 4 times 5 is 20. And now we want to simplify. What can we divide both 2 and 20 by? I can divide them both by 2. Now, I know some of these things are mental steps here. You're doing mentally 1 times 2, and you're doing mentally 4 times 5, mentally dividing that 2. But I want to show those steps for our first example. So what is this simplified? 1/10. So since that is my final answer, I'm going to box it in, or if you prefer circles, that's fine. Now, is there another method of doing this problem? Does anyone know a way that sometimes can be a shortcut? Yes. Well, we're going to not call it cross multiplying. We're going to call it cross reducing, okay? So cross multiplying is if you like really multiplied. But we are looking diagonally. So I'm going to rewrite this same problem, okay? And what you mean, correct me if I'm wrong, is that you're looking diagonal. So you're looking at the 1 and the 5. You're looking at the 2 and the 4. And before we ever multiply, we're going to think about simplifying. Is there anything that I can divide 1 and 5 by? No. Is there anything I can divide 2 and 4 by? Yes. I can divide the 2 and the 4 by 2. And when I do that, this is going to become 2 divided by 2 is 1. 4 divided by 2 is 2. So now then I would go through the steps of multiplying straight across. So now on top I have 1 times 1, which is 1. And on bottom I have 2 times 5, which is 10. So there is that same answer. So again, basically what you're doing is you're simplifying first before you multiply. Raise your hand if you were taught that way, whether last year or the year before or sometime. So about half of you, the other half of you were not ever taught that? I think it'd be very helpful if you use that method. It's not a requirement, obviously. You can still get the answer, but sometimes you have very big numbers, especially when we're using mixed numbers. So if you cross-reduce, it is going to save you a lot of time when you can't use calculators and stuff to help you with multiplying. All right, so let's work on what you would do. This is a fraction times a fraction. Let's do a fraction times a whole number. Again, a fraction times a whole number. Let's say we have the problem 2/3 times 5. So we can't just say multiply the numerators because we don't have a numerator over here. So who remembers what you should do for this, Stephanie? Very good. So anytime you have a whole number, you can turn a whole number into a fraction by putting it over 1. So I'm going to rewrite this as 2/3 times 5 over 1. Some people get confused and they think, oh, I'll put a 5 over 5. What does 5 over 5 equal? 1 whole. Okay? All right, so now we can use our steps. Now I'm going to look, can I cross reduce? 2 and 1? No. 3 and 5? No. So I need to go ahead and just now multiply. So 2 times 5 is 10. And 3 times 1 is 3. That's improper, so I want to change it into a mixed number. So mentally, and again, I'm going to show my mental steps up here for our notes. I'm doing mentally, how many times does 3 go into 10? 3 whole times. That would give me 9. So I'd have 1 left over. So my fraction is going to be 3 whole times. My numerator is going to be my remainder. And then my denominator stays the same, which was a 3. So 3 and 1/3. And again, since this is my final answer, I'm boxing it in. All right, so that's how you do a fraction times a whole number. Any questions about that? All right, so let's do a mixed number times a mixed number. So mixed numbers. So for mixed numbers, I gave you the option when we were adding and subtracting mixed numbers of leaving them mixed numbers and adding and subtracting them, or turning it into an improper fraction and doing it. You had the option. When you are multiplying and dividing, you don't have an option. You have to turn it into an improper fraction. Must turn into improper fractions. You have to. If we have the problem 4 and 1/3 times 6 and 1/2. So we cannot do 4 times 6. We can't multiply our whole numbers and get 24 and then do 1/3 times 1/2 and get 1/6. 24 and 1/6. We'll see. That's not going to be our answer, our correct answer. All right, so let's review briefly how to turn a mixed number into an improper fraction. I know we talked about it briefly last week also. Someone want to walk me through how to change that, Daphne? Good. So we're doing 3 times 4, which is 12. We're doing 12 plus 1, which is 13. So that's going to give me 13 over 3. Same process for 6 1/2. I'm going to do 2 times 6 is 12. And 12 plus 1 is also 13. And that's going to give me 13 over 2. Can I cross reduce? 2 and 13 can be divided by anything? No. 3 and 13? No. So unfortunately, I'm not going to be able to help myself out too much with that. So now I need to just multiply 13 times 13. Does anyone have that one memorized by any chance? You do? Very good. It is 169. So if you don't have it memorized, then remember, you can always go old school and work it out over here, right? No one really likes to do that. Or maybe you do. Who knows? So 169 over 6. Now that's a bigger number to simplify in your head, doing 169 divided by 6. So anytime you have something that it's harder to do mentally, take the time, take the extra few seconds to actually write it down so you can see it. It's going to be a lot easier for your brain to process it. How many times will 6 go into 16? 2 times. And 2 times 6 is 12, so that's going to leave me 4 left over. And I'm going to bring down my 9. How many times will 6 go into 49? 8 times. 6 times 8 is 48. And that's going to leave me 1 left over. So my remainder is 1. So when I write this as my mixed number, 28 is my whole number. My remainder is my numerator, 1. And my denominator remains a 6. 28 and 1/6. All right, any questions about that? Any place that I lost anyone? All right, you're pretty quiet, so I'm assuming that we're all okay, yeah? I know this is review, but still. All right, so let's talk about dividing then. Let's talk about dividing. What do you know or what do you remember about dividing fractions? Dividing fractions. Daphne, what do you remember? All right, so it's basically multiplication, except the second fraction is flipped over. Do you all agree with all that? Very good. When you flip over a fraction, it's called a reciprocal. Was there a phrase that you were taught in elementary school to help you remember that? Same, change, flip. I taught 5th grade for 5 years, so I always taught people same, change, flip. You keep your first fraction the same, you change your division sign into multiplication, and you flip, or take the reciprocal, of your second fraction. So it's always the second fraction that you're flipping, that you're doing the reciprocal of. And again, the flip, you spell reciprocal like that. So we should all be familiar with that word, reciprocal. So let's practice doing that. If you had 3/5 divided by 1/4. So we want to rewrite this as a multiplication problem. Who'd like to tell me what it is? Sarah, you want to tell me what the problem is when you rewrite it? Yes? Perfect. 3/5 times 4/1. All right, so we're looking to see, can we cross reduce? 3 and 1? No. 4 and 5? No. So we're going to go ahead and multiply straight across. 3 times 4. 5 times 1. 5 goes into 12. How many times? 2. That'd give me 10. So how many would I have left over? 2. So 2 and 2/5 is my final answer. We're going to do 2 more examples, okay? Because I want to do one example of doing a fraction divided by a whole number and one example of mixed numbers, and then we'll be finished. That way you have all examples in your notes. All right, so let's do a fraction times a whole number. Let's say we have 5/6 divided by 3. Now before we do same, change, flip, we want to go ahead and make this so it's a fraction divided by a fraction. So the first thing that I'm going to do is I'm going to rewrite this as 5/6 divided by 3/1. Now I'm going to do same, change, flip. Sometimes people try to do those 2 steps completely together in their head, and they mess up when they're writing this 1/3. They leave it at 3/1. All right, any cross-reducing that I can do on this problem? No. So multiply straight across. 5 times 1 and 6 times 3. Can I simplify 5/18? Nope, so I'm finished. Any questions about that one? Am I going at an okay pace? I'm not going too fast? I know we're covering a lot of stuff, but it should be review. So, all right, let's do our last example. It's going to be our mixed number divided by a mixed number. Let's say that we have 5 1/6 divided by 4 3/4. So again, before I do same, change, flip, I want it fraction divided by fraction. So let's change these into mixed numbers. What would 5 1/6 be as a mixed number? Anyone? Yes? 31/6 divided by, what would 4 3/4 be? 19/4, very good. All right. Now I'm going to do same, change, flip. So same, change, flip. I'm going to look to see if I can cross reduce. Now my 31 and my 19, they're prime numbers, so unfortunately there's nothing I can do with those. What can I do with my 4 and my 6? I can divide them by 2. Now that's going to help me some. It's not going to completely get rid of those 31s and 19s and make them easy to work with, but it is going to help some. So 4 divided by 2 is 2, and 6 divided by 2 is 3. So again, that will help me. Now I can multiply straight across. 31 times 2 is 62. And 3 times 19, it is 57. Don't be afraid to work stuff out. How many times will 57 go into 62? 1 time. How many would be left over? 5 left over. And that is then your final answer.